Hi everyone, let's talk a little bit about multi-views. I want to give you a little more detail. You've drawn a couple now and just by copying them. And what I'm going to do is I'm going to go over a quick PowerPoint. I'm not going to go through all of this, but when we talk about the views of an object, what we're looking at is what does it look like from one direction. Most objects have 6 views. Those 6 views are the front and back, the left and right, and the top and bottom. So when we look at something from the front, what we're going to see is 2 of the 3 basic dimensions, which is height, width, and depth. So as you see in the image below, the gentleman here is looking at the front of the object and he sees the width left to right and he sees the height top to bottom. He can't see depth looking at it this direction. So with that being said, how do we draw this view? Well, what we do is put a piece of glass in front of it and trace what you see from the front. So the top part of this is curved. Then you've got the straight sides going down. And in the base of it, here's the top of the base, here's the bottom of the base, and then the little slot cut through it from the front is going to look like that. So you're going to see a rectangle, and a rectangle representing the base. The top, you're going to see the rounded part and the hole cut through it. So again, our 6 principal shapes, or 6 principal views, is front, rear or back, top and bottom, right side and left side. So think about if we had a house. If we walked around a house, it would be the same thing. You've got the front, the right side, the left side. If we look down at it from where a bird would sit, that would be the top. If we looked up from the basement, that would be the bottom. And the rear of the house, looking at it from that direction. So how do we get it from where we're looking at it? Let's take the object and rotate it. So if we held it in our hand and was looking at the front view, now we rotate it, rotate our right hand up, as you see the person's holding it with the right hand, and the fingers are behind it and the thumb is in front of it. When we rotate it around, that's our top view. Now our fingers will be on top of it and our thumb will be on the bottom of the object the way we're looking at it. If we hold it in our fingers the same way and we rotate it to the right, now our thumb will be facing toward the left and our fingers will be facing to the right. And we're going to see a backwards L for the right view. That's how you rotate it around. And if you notice the picture up here is what we would draw. Here's our front view again. We've already seen it. Our top view, notice the shape that we see here. Sort of the U shape and then the rectangle. Here's our U shape and our rectangle. The right side, when we rotate it, is this L shape with a rounded corner. This is called a fillet. An interior rounded corner is called a fillet. You've heard of that in AutoCAD. We've also got center lines and hidden lines. These are hidden lines. We see them here also, short dashed lines. And then we have center lines. Here's one, and here's 2 crossing. These are used to show circularity or symmetry. The hidden lines are used to show features or edges that we can't see. We'll get into them a little bit later. Okay, we work in what's called the third angle projection. We're not going to worry about this too much. It's just a term you sort of need to know. Okay, so in third angle projection, we again project out what we see onto the front, onto the top, and onto the right side, just like if it was sitting inside of a glass box. So when we look at it in third angle, if we look all the way down here, our third angle projection will be laid out like this. It's always going to look like a laid over cross. Everything hinges on the front view. Our top will be directly above it. Our right side will be to the right. Our left side will be to the left. The bottom directly below it. And the rear or the back goes out beyond the left side. If you notice, these 4 views all share height. These 3 views all share width. Now this view, this view, this view, and this view all share depth. And then of course the rear and the front share width as well. Okay? So transferring dimensions over, so this is a picture of like an old-timey TV. If you notice, we can take these and curve them around and get them in the right place. Pretend like you're parking a car. So if we had a car and we're driving along, if we come along and park it, it would park right here. So the width here, the depth here would stay as the depth here. Okay? So again, our principal dimensions are height, width, and depth. As we said before, And when we go to draw, we're talking about that projection method. So again, pretend like we've got a glass box or a glass plate sitting in front of the object. We project the edges out onto the plate, and you project the points, and then you connect them with your visible lines. Remember, edges that we can see are drawn with visible lines or object lines. Either one is correct. Same thing for the top and for the right side. We project out on and we draw visible or object lines for the shapes we can see looking that direction, hidden lines for the shapes we can't see, and of course center lines show circularity. Okay? And here's that glass box method just as we talked about. Once you get it all drawn on the box, we can unfold the box to create that laid over cross shape that we talked about. And right here it is again. This is a really good image to see here. Okay, so to transfer depth, if we're drawing it by hand, we could do it with a set of dividers. We could measure it with a scale or a ruler. The easiest way to do it is doing it with a miter line. So if I've got my outside edge of the right side and my outside edge of the top, if I connect those with a construction line and draw a 45-degree line down between them, I can project everything else. So this edge comes over and hits the miter line and comes down. This edge would come over and hit the miter line and come down. And this one would come over and hit the miter line and come down. They will all line up that way. Okay? And again, this is really getting into it kind of deep here, because now what we've got is dimension 2 here is the same as dimension 2 here. And whatever distance we are off of our different planes, we're going to stay that way. Okay? The alignment of views, again, this is important. The top is always directly over the top. If you notice again, width, this lines up, this lines up, this lines up, the whole lines up. The quadrant here lines up with the hidden line here, and the same here, and our center lines line up. The height lines up from the front view to the right side. You never want to draw these views just out in space or somewhere odd. Okay? So picking the necessary views, you only want to draw the views that it takes to completely describe the object. Those are your necessary views. And we have talked about that a little bit before. A lot of objects can be fully described with 2 views, but most take 3. Okay? If it's a really simple object, we're going to draw 2 views. And notice here, this is preferred over this. The reason why, the paper's turned sideways, so it's a little hard to get it to fit. Same thing here, because of the length of this object or the width of this object, it's better to draw these 2 views than it is these 2. Okay? Sometimes we can draw it with just a single view. If something's really thin, like this part here, the reason why they only drew 1 view is because it's only 1/4 inch thick. As you can see down here, MTL stands for material, and it says 0.25 brass, so it's 1/4 inch thick. This object is circular. So it's a really simple, plain feature to draw and everything. And it's made out of it's made out of square stock. And it's made out of 65mm square stock. So it's pretty straightforward what it is, okay? The last thing I want to show you here on this is I do want to show you what could happen with the views. If you notice, look at all 5 of these shapes. So from the top, surface A, B, and C, notice the arrangement in this view. We've got a rectangle and then 2 more rectangles. Well, that's the correct top view for that. But notice this, A, B, and C. B's lower than C this time. From the top, it's still going to look the same. Here, B is taller, A is the lowest surface, same thing. Here we've got an inclined surface, it's on a slope, but we still see a rectangular shape and it just goes over to the right-hand side. So the 3 things we'll see in the top is that as well. And in the exact same thing here, we can have a fully rounded top, but if you look straight down on it, it would look like a rectangle. And in this triangle, we would see a rectangle on this side and a rectangle on this side. So this is the correct view, top view for all 5 of these. That's the reason why you have to draw more than 1 view. That way people can tell exactly what they're looking at. You've got to give enough information. So what we do anytime we've got an inclined surface, find your corners and then project them straight out. So this FS stands for foreshortened. In other words, this line here is a lot longer than this is because all we're doing is going from top to bottom to get this. Here, if it's a square or just a rectangle that's parallel with this, it's the true size and shape. But here, this rectangular surface will be shorter in the picture than it actually is in real life. Well, that's all I'm going to do on this today. I'll go over and I'm going to draw another drawing for you, and we'll go through it, and I'll show you some of these things. Thanks, and have a great day.